So we're in 0.1. We're going to finish up 0.1 fairly quickly, hopefully, this morning. And any questions from last time? Anything that might have come up? I don't know if you've tried to look at the homework or not, but anything come up in the homework or during the lecture? I'm watching the chat over here too. Well, if that's the case, I'm just going to get started. So let me just see, is my head really cut off? Let me fix that real quick. Still a work in progress here. Hopefully that's a little better. A little better. Still sort of figuring things out. So what we talked about last time, we talked about reducing fractions. So I just want to review that real quick this morning. So let's say we have something like this. Now, what we learned to do last time is we can break these down into prime factorizations. And a prime factorization is when we turn a number into just a product of prime numbers. So 90 9 times 10. And then we can't go any further. Remember, a prime number is a number. It's a whole number. No fractions, no decimals in this exercise. Where we, except for this fraction here, where this number 3, for example, the only two numbers you can multiply to get 3 are 3 times 1. The only two numbers you can multiply to get 5 are 5 times 1. The only numbers you can multiply to get 2 are 2 times 1. Again, in this multiplication process, we're not letting ourselves use fractions or decimals. 300, so look at this. So you have 10 and 30. Now I'm circling my prime numbers. And so that's the prime factorization of 30. Now, to reduce this, what we're going to do, we're going to rewrite 90 and 300 using just the prime factorizations. So you have 2 times 3 times 3 times 5. So 2 times 3 times 3 times 5, that's going to give you 90. Now for this one, we have 2 times 2 times 3 times 5 times 5. So to actually go through and reduce these, we need to come up with what's called a common denominator. Oh, no, sorry, not common denominator. We're going to actually cancel out numbers. So erase this. Now, when we cancel, we can only cancel 1 for 1. In other words, if I cancel a 2 here, since I'm only canceling 1, 2, there's only 1, 2 on the bottom that can cancel also. Same thing with the 3. Because there's 3's in the tops and the bottom, I can cancel 3's, but only 1 for 1. Same thing with the 5. I could cancel those 2 5's. And so what that's going to leave it's going to leave 3/10. Any questions about that? Now, there's one question I'm sort of leaving undecided. Let me grab my little eraser. That question that we didn't get to answer last time is how do we tell if different fractions are bigger than each other, especially when the bottoms are different? Well, last time when we looked at reducing fractions, we learned about this idea that we can divide the top and the bottom by the same number. That's allowed in mathematics. So if we want to reduce, say, this fraction, we could list out the prime factorizations, but we might also recognize I can divide this by 2. I can also divide that by 2. And so using this other approach to reducing fractions, we can reduce 2/8 into 1/4. Now, if we did this using prime factorizations, now 8 is 2 times 2 times 2. And so we can cancel the 2's, or at least a pair of 2's. But then what we're going to get we get a blank spot on top. Now, when we reduce fractions, whenever we get a blank spot, whether it's in the top or in the bottom, we always fill that blank spot with a 1. And so we'll get the same answer, 1/4. Now, before I go back to this idea of how do we figure out which fractions are bigger, let's talk about this 1/4. Why are we doing this? Why do we put a 1 there? There's a trick. Let me show you. Now, 2 is a prime number. So that means 2 is only the product of 2 with the number 1. Now again, we're leaving out decimals and fractions. So I can rewrite 2 as 2 times 1. And then I cancel my 2's. And that gives me 1/4. And so that's where that 1 comes from. Now, when we use it in this method, when we just break everything down, cancel everything out, and then write in the 1, that's just a little faster. You don't want to have to take the trouble to write a times 1 in here. Because anything times 1 doesn't change anything. You can always multiply by 1. That accomplishes absolutely nothing, which is fine. It doesn't change anything. But that's why we're filling in those 1s. Now let's go answer that question. So let's say we have something like this. Which fractions are bigger than the others? Can we put these in increasing order? Well, you can think of it like this. Think you had a quiz, and there's 8 questions on the quiz. And this is the number of questions somebody gets right. So this would be a score of 3 out of 8. This would be 7 out of 8. And this would be 5 out of 8. Now, I want to give you some vocabulary. I've been using the term bottom number and top number. The more exact names for these: bottom number, we call that the denominator. The top number we call the numerator. So as long as the denominators are all the same, as long as the bottom numbers are all the same, we can place these fractions in order by using the top numbers. So of these 3 fractions, because 3 is the smallest numerator, and again, this only works when all the bottom numbers are the same. Since 3 is the smallest numerator amongst these fractions, it's going to go first to be the smallest fraction. The next largest fraction would be 5/8, and then the next largest fraction would be 7/8. So that's how we can put these in order. But let's say we're given a slightly different problem, something a little trickier. And we're going to start getting into this in the next section. Let's say these bottom numbers are not the same. What do we do? Now let's say we want to put these in order. So it's sort of like asking, what's a better score? 1 out of 2, getting a 3 out of 10, or a 7 out of 100. Now last time, we just looked at these numerators, these top numbers, and we said, Well, the smallest numerator means we have the smallest fraction. But that only works if the bottom numbers are the same. They're not the same here. Now, we talked about this math trick where it's okay to divide the top and bottom of a fraction by the same number. You can do the same thing with multiplication. Now, I like to try to avoid writing all these big paragraphs, but this one's really important. There's three things. You can divide, you can multiply, and it's got to be the same number. So you can divide top and bottom by the same number, like we did earlier. We divided, let's say we had 2 over 8, so we divided top and bottom by 2. In this case, you could also multiply top and bottom by 2 if you wanted to. The key thing, though, you can only divide, you can only multiply. This does not work with addition or subtraction. Doesn't work with addition or subtraction. Also, when you divide or multiply, you have to use the same number. You can't multiply by 3 in the numerator and then divide by 2 in the denominator. No go, that won't work either. So you want to stick to this fairly closely. Now, how is this going to help us? Well, to compare fractions, what we did last time is we used the fact that we had the same bottom number, the same denominators in each fraction. And as long as we have that, then we can look at those numerators and use the numerators to figure out which fraction is bigger. So we need to turn each of these bottom numbers into the same number somehow. Let's look at how we can do that. Well, I've got an idea. Let's turn 2 and 10 into 100. Now, we can only use division or multiplication according to our math trick. And whatever we multiply or divide to the 2 or to the 10, we have to also do it to the top number as well. What we do to the bottom, we have to do to the top. What we do to the top, we have to do to the bottom. So what we could do, if we multiply 2 by 50, that will turn 2 into 100. So I'm using multiplication or division, and then I'm doing the same thing to the top and bottom at the same time. So this is how that math trick works. So this means we're okay. So that means to turn this fraction into a fraction where the bottom number is 100, the top number becomes 50. Let's use the same trick on 3 tenths. We want to make sure that 10 becomes 100. Now, 10 times 10 is 100, so I went for multiplying by 10. But what I do to the bottom, I have to do to the top. And that forces this fraction to become 30 out of 100. So it turns out that 1/2 is the same as 50 out of 100. 3 tenths is the same as 30 out of 100. So now we use these fractions to put things in order. Because they have the same denominators, now we can just use the numerators to figure out which fraction should go first. So clearly this is the bigger denominator. So that means 50. Actually, we're going to do this in increasing order. So you want to look at the smaller fraction. It's going to be this one. The 7 is the smallest numerator. Then 30 out of 100. And then 50 out of 100. Now, we've got these modified fractions in order, but we want to remember 1/2, I'm going to show why this is true, is equal to 50 over 100. They're the same quantity. It's just 1/2 of 2, 1/2 of 100. So we can, instead of 50 out of 100, oh, sorry, this is 30. We can put in 1/2. And 30 out of 100 is really just 3 out of 10. And then we have 7 out of 100. So if we place these fractions in order from smallest to largest, that's what we're going to get. So any questions about that? So how come this works? Well, to do this, we got to talk about multiplying fractions. And we're going to get to that right now. Well, to talk about multiplying fractions, I have to make a bit of an assumption of the use of the language. For example, let's say we want 1/2 of 10. What is 1/2 of 10? Well, 1/2 of 10 is going to be 5. So another way we can come up with this is we can say that this is equal to 1/2 times 10. So this is sort of a convention in mathematics, and if I can think of a better way of expressing this, I will. I'll let you know. I can do a video that kind of illustrates why this use of language is leading to this. But you can sort of think of it like this. Twice 5. What's twice of 5? And we can say that's 10. So half of 10, we can say is 5. So I'm just going to talk about this a little bit. So sort of the same way, we can say half of 10 is 5. So a little bit going on here with the language, but let me give you a visual example. This might be a little better. Let's say we want half of 1/4. Well, half of 1/4 is going to mean 1/2 times 1/4. So the answer to our question, what's 1/2 times 1/4? We're going to answer that question by computing half of 1/4. So how do we figure out what's half of a 4? Well, let's draw a picture. So here we have something divided into fourths. So here's a fourth. Now we want to know what half of that is. So to figure that out, let's divide it in half. And so what we have here is 1/2 of 1/4. So I don't know if you can see that or not, but this is 1/2 of 1/4. Try to write it bigger. So how much is this quantity? Well, we know it's not the whole thing. That's the whole thing. So this is just a part of the whole. But how much of a part, or how small of a part? Well, one thing we can do, let's divide each of these fourths in half. So if we divide each of the fourths in half, there'll be 1, 2, 3, 4, 5, 6, 7, 8 pieces that make the whole. Now, when we look at just a half of a fourth, this right here, this one piece, we're only looking at one out of these 8 pieces. So half of a fourth, well, that looks like it's equal to 1/8. So what this tells us is this. One half times 1/4 is 1/8. Now, I'll be honest, every time you have to multiply fractions, if you have to draw out pictures like this, it's going to take a long time. So there's a shortcut. You don't have to draw a picture each time. Now, one of the things in this class we're going to learn is shortcuts. One of the hard things about arithmetic and algebra is why do people do the things they do? And a lot of times they do them because it's a shortcut for something more complicated. So if we take 1/2 times 1/4, how can we get 1/8? Well, here's the slick trick. This 8, we can get that 8 by multiplying 2 and 4. And we can get this 1 by multiplying the 2 ones on the top. So here comes the trick. If we have 2 fractions that we're multiplying, to find the numerator or the top number, we multiply the top numbers. To find the denominator or the bottom number, we just multiply the denominators. And that's going to give us our answer. Now we can answer all kinds of questions using this trick. So for example, let's say we have 2/3 times 1/5. Well, what we're going to do is just multiply across. And that's it. That's how we're going to multiply fractions. We just multiply across, and that's it. Questions about that? So that's multiplying. What about dividing? Well, before we get to dividing, I want to go back to that whole business of multiplying top and bottom. I said that 1/2 is the same as 50 out of 100. And I made sort of a qualitative argument that 1 out of 2 is the same amount as, say, 50 out of 100. So if you took a pizza and you cut it up, say, into 2 slices, and then I took another pizza cut it up into 4 slices. Here, 1 out of 2 is the same quantity as 2 out of 4. You get the same amount of pizza. So that's the sort of the quantitative approach. How can we do this computationally? If I'm going too fast, let me know. I can slow down. One half is equal to itself times 1. Because you can always multiply it by 1. Multiplying by 1 doesn't change anything. But we can be clever about this. One you can represent as a fraction. For example, 1 over 1. 1 divided by 1 is 1. You can do 3 over 3. 3 divided by 3 is 1. And I don't know if I've mentioned this before, but fractions just represent division. So if you take the fraction 8 over 2, this is actually 8 over 2 is to 8 divided by 2. Fractions and division are the same thing. That's just a mathematical convention. So keep that in mind. So this is what we're going to do. I'm going to write 1 as a division, or a fraction, of 50 over 50. Now, if you're still wrapping your head around this idea that fractions and division are the same thing, you could think of a whole is 50 parts out of 50 parts. You have the whole thing, or 1 whole. So I can write 1 as 50 out of 50. And then I use my rule for fraction multiplication. And so we get that 1/2 equals 50 out of 100. Any questions about that? That's just something I wanted to show you before we get into fraction division, just sort of an off to the side thing. All right. Let's get into fraction division. So the takeaway so far, you want to multiply fractions, just multiply across. Multiply numerator to numerator, and then multiply denominator to denominator. To do division, let's say we're going to answer this question. One half divided by 1/4. Now, another way of thinking about this, we could ask this question: how many times does 1/4 go into 1/2? how many times does 1/4 go into 1/2? So what we can do is we can go back to a picture. We can take something, divide it into 2 equal halves, and then look at how many times does 1/4 go into one of those 1/2s. So let's take a look. So here's our whole. Maybe it's a large tray of pizza, maybe it's a tray of brownies or something. We're going to cut this in half. Relatively 2 equal halves, close. Now what I'm going to do is I'm now going to divide this into 4ths. So I want to divide this in now 4 equal pieces. So the question we want to answer is, how many 4ths appear in a half? Well, let's take a look at one of these halves. I'm going to label my 4ths. So let's take a look at this first half. How many 4ths are in this half? Well, there's 2, just like there's 2 in this other half. So what this says, that's equal to 2. Now, again, if we have to divide fractions, and every time we do, we need to draw pictures, we could be here a long time. And some of these pictures could be really complicated to draw. For example, if we're going to divide 5/17 by 1/1000th, that means we'd have to take something that's a 5/17. We'll take a whole, divide it into 17 parts, circle 5 of them, and then we got to take the whole again, divide it up into 1,000 more littler pieces, and then count how many littler pieces are in the 5/17 that we originally drew. That's going to be tedious. Can we come up with a shortcut? And it turns out we can. And I'll admit, how people see these shortcuts, I don't know. Some of them are pretty clever. So 1/2 divided by 1/4 is equal to 2. I'll be honest, this isn't something I would have seen. How can we get this 2? Is there something we can do with these numbers to come up with the 2? So this is what they came up with. Let's leave this alone. I'm not going to do anything with it. But the second fraction, we're going to flip it. And then what we're going to do, we're going to change the division sign to multiplication. Now we have a way of multiplying fractions. We just multiply across. So 1 times 4 is 4. 2 times 1 is 2. And this is 4 divided by 2. Again, fraction. Equals division. So 4 divided by 2 is going to give us 2. So that's how we're going to divide fractions. Any questions about that? We'll do another example. So let's take a look at 5/17. Divided by 1/1000th. Well, we're going to keep the first fraction. So the first one we keep. The second one we're going to flip. And then finally we change the division sign to multiplication. And now we use our trick for multiplying fractions. We just multiply across. We get what's called an improper fraction. Proper fractions, the numerator or the top number is always smaller than the bottom number. And an improper fraction, the numerator and the denominator equal each other, or the numerator is bigger than the bottom number, the denominator. So this is an improper fraction. Questions about that? So let me go over the types of fractions. I'll just mention that real quick. So we actually have types of fractions, sort of in the same way you have types of dogs or cats. We have sort of breeds of fraction. And the first one's the proper. A proper fraction is where the top number is always smaller than the bottom number. So an example of a proper fraction would be 3/10. Then you have what's called improper. There are two types of improper fractions. The most common, I think, you run into is when the top number is bigger than the bottom number. The other kind you run into, when the top and bottom numbers are the same. Those are improper. Now, the other kind of fraction you run into is called a mixed number. A mixed number is really a composite. It's a whole number with a fraction. So you might have seen something like this. This is 5 1/3. Or you might see 2 1/2 or 2 1/2. This has a special meaning. It's 5 plus 1/3. So when you have a mixed number, you have the whole plus a little bit more. So those are examples of proper fractions, improper fractions, and mixed numbers. And of course, there's many kinds of these you can come up with, like 2 1/2, 10 1/5, 7 halves, or 7/2. And of course, we've seen all kinds of proper fractions. But this is how you often see fractions. So any questions about that? So let's see. So next, so adding and subtracting. Now, the way we add and subtract fractions, let's say we have pizzas. So we have 1 slice out of 4. Here we have 2 slices out of 4. So let's say we're going to do something that from time immemorial in college, at some point you go to a pizza party or a party, you got to combine all the pizzas and the pieces into one box. So we're going to take this piece of pepperoni and put it in the same box with the pepperoni and green chili. That's a good one. So when we combine these, what we're going to get are 3 out of 4 slices, or 3/4. So with this 3/4, can we come up with an easier way of getting it than having to draw all these pictures? There actually is a shortcut. So we want to look for a pattern or a trick that will let us do this. And there is a trick. To get 3/4, from these fractions. We'll keep the denominator. We'll just carry it through. But then we'll add the two numerators. Finally, we get to do some adding. And so that's going to give us 3/4. So this is how we're going to add fractions. Now, there's a key restriction, though. The denominator always has to be the same. The two denominators have to be the same. So if the denominators aren't the same, technically there's nothing we can do. We cannot add those fractions. The denominators have to be the same. Let me do another example. So because these two fractions have the same bottom number, the same denominator, we are allowed to add them. So we're going to use our trick. We keep that same denominator. And then we go sum of the numerators. So this will give us our answer of 7/19. So any questions about that? So now you know this, and you probably know this from, say, high school, or if you've taken an algebra class before. The whole thing with fractions is you do get to add fractions with different denominators. So how do we do that? I just said we couldn't. There's a trick. So now we have different denominators. The trick is going to be this. I abbreviate denominators. We want to make each denominator the same. We want to turn them into some number. We want to turn each denominator into the same number. Now, there's lots of different numbers you can use, but the one I'm thinking of here is 12. So let's take 3. If we multiply 3 by the number 4, we're going to get 12. And then if we take 4, that denominator, and we multiply by 3, we're also going to get 12. So the key to do this, the trick, for 3, you have to multiply by 4. And for 4, to turn it into 12, we have to multiply by 3. This is what's called a common denominator. The number 12 is a common denominator. So now I just need to go through with this. So to turn this into 12, I'm going to multiply by 4. But remember our rule with multiplication and dividing when it comes to the top and bottom number. What we do to the bottom, we also have to do to the top. That's an ironclad rule. Same here, to turn 4 into 12, I multiply by 3. But what I do to the bottom, I also have to do to the top. So now we'll have eight over 12 plus 3 over 12. And now we can add these fractions. Because they have the same denominator, we can finally add them. And remember, we keep the common denominator. We don't add the 12s. We keep the 12. We only add the top numbers. And that's going to be your answer. Now, one thing I want to warn everybody about with multiplying, dividing, adding, or subtracting fractions, you sometimes have to reduce them. So once you've done your math, you might think, well, I'm done, it's all finished. Careful, there might be more to do. Let's see. So, let's say we have something like this. Well, we want to get a common denominator. Now, we want to turn these into the same number. But this one's going to be a little easier. The reason is we can turn 7 into 28 by just multiplying by 4. And then, of course, 28. It's already there. We don't have to change anything. So we'll get this. we can multiply top and bottom by 4. And then we do for subtraction the same thing we do for addition. We can only subtract fractions if the denominators are the same. And because these are the same, we can subtract them. And we go about it the same way. We only subtract the numerators. So any questions about that? All right. So one last thing I do want to mention. When working with fractions, sometimes you'll get whole numbers thrown in there. So for example, you might get something like this. The way you handle this is we want to turn this into a fraction. We can always turn whole numbers into fractions by giving them a denominator, a bottom number of 1. And so now we just have to give this a common denominator. We can easily turn 1 into 3 by multiplying by 3. But what we did to the bottom, we have to do to the top. So now they have common denominators. We keep the common denominator and we add the 2 numerators. And that's going to be your answer. The same thing with division or multiplication or subtraction. Whenever you have a whole number, rewrite it as that number over 1. And then you can go ahead and do the operations. Any questions about that? All right. So we're going to get into section 0.3. We'll just kind of give an intro to it today. And so 0.3, there's basically, we're getting into decimals. What we're getting into is how our number system's put together. And we have what's called a base 10 number system. So that means when you have digits, to get into different places in a number, let me show you. Let me put it to you this way. So we're base 10. So let's say we have a number like this. So we've got our decimal point. This place here is called the tenths. I'm sorry, ones. The next place is called the tens. And finally, this place called the hundreds. So you have ones, tens, hundreds. Now, what's going on here? We have 1, one times 10, which is 10. And then we have 1 times 10 times 10, which is 100. So what's happening here, every time we go from one decimal location to the next, we multiply by 10. So if at the ones, we multiply by 10 to get to the tens. If we multiply the tens by 10, we'll get to the hundreds. And so that moves us along. Now, that's if we're on this side of the decimal point. So what this looks like, and grab my eraser. If we just focus on this side here, 324 is 300 plus 20 plus 4, or 3 times 100 plus 2 times 10 plus 4 times 1. So you have the ones place, the tens place, and the hundreds place. So that's how we work to the left of the decimal. Now, any questions about that? Let's take a look at this other side. Now, this could be a little confusing, but this place here is not the ones. This is the tenths. Followed by the hundreds. And then the thousands. So you have tenths, hundreds, thousands. Well, the way tenths work, in the tenths, what we do is we take 1 times 1/10. That's a tenth. For 100, it's 1 times 1 over 100. And for the thousands place, it's 1 times 1 over 1,000. So this is a tenth. Oh, I'm sorry. Pardon me. Let me go back. So for a tenth, what we did to the left of the decimal is we multiplied by 10. To move along the right side of the decimal, we're not going to multiply. We divide by 10. And that gives us a tenth. For the hundredths, we divide by 10 again. 1/10 divided by 10 is 1 over 100. And finally, for the thousands, 1 over 100 divided by 10 is 1/1000. So to the left of the decimal, we multiply by 10. To the right of the decimal, we're going to divide by 10 to go from place to place to place. So here we times 10 to go further out. On this side, we divide by 10 to go further out in that direction. So if we start with 1, we divide by 10, we get a tenth. That's our tenths place. So we take the ones place, divide it by 10, we go over here. If we take the hundreds, to get to the hundreds, we take 1/10, divide by 10 again, and we get to the hundreds. And then we take 100th, divide by 10, that'll move us again to the right to get us to the thousands. There's a general idea here. If you want to go to the left, you always multiply by 10. If you want to go over to the right, you divide by 10. Anyway, that's where these names come from. And that's where we're going to run out of time. So we're going to pick up this again Monday. So what we're going to do, I'm just going to quickly review the names of these, like hundreds, tens, ones, tenths, hundreds, thousands. We're going to go over how to name these numbers, and then we're going to jump into the operations. How do we add decimals and subtract them? How do we multiply and divide them? And again, we're mostly just going to be working with tricks, little shortcuts we can use, and hopefully that'll make everything a lot easier. And then after that, we'll be looking at fractions and percents. So that's where we are. If you have any questions, let me know. What we've covered so far in the class is section 1.1, 1.2, and the very tiny beginning of 1.3. And we're going to pick up a little pace. We're a little behind on schedule, but we'll pick up pace next week. We should be able to get through the decimal portions fairly quickly, and then we'll just go on from there. So that's it for class. I'm going to stop recording, and I'll see you in the lab. Again, in Blackboard, go to the lab section, click on the link for the lab section, and I'm going to have about 3 or 4 problems actually for you to work on, just to practice. You want to send those answers to me through Blackboard Messenger. And then for the rest of the class, work on your homework, and I'll answer any questions you have. All right. So I'm going to switch over to the lab right now.